Hello everyone, so today we will be solving Leetcode problem 11, that is container with most water. So we are given an integer array height of length n. So there are n vertical lines drawn such that two endpoints of the ith line are I 0 and I, that height of that index I. So we have to find two lines that together with the x-axis form a container such that the container contains most water. And in here we are given an height array, and this is kind of like the output, that is 49 for this example right here. So the above vertical lines are represented by the array, that is 1 for this first one, then it is 8, then it is 6, then it is 2. So the max area of the water the container can contain is 49. So this is the max area that the container can contain. Now let's head over to our drawing explanation to understand this problem more and then code it. To solve this problem, we will use two-pointer approach. So we will take two pointers, that is left pointer and right pointer, and then we will try to find the maximum area. So how we can do that? So our left will begin at 0, our right will begin at length of height minus 1. So we will take two pointers and we will find the current area. We will find the current area while our left pointer will be smaller than our right pointer. So we will be running the loop while our left would be smaller than right. We would find the current area which will be equals to, we will find the minimum of the height at left and the height at right, whichever is minimum we will take that into consideration, and then we will multiply that with our area, with our width, with our width. So it will give our current area. Now we will have max area, where it will find the maximum between the max area, which would initially be 0, and we would update it, and current area. So if our height at left will be smaller than our height at right, we would move inward. We would move inward, like our left will move to this place. If our height of left will be smaller than our height at right, we will be moving inwards towards the array. So we also need to find a height which is greater, and we also need to find the width that would be sufficient. So else, if our height at left is greater, then we will move inwards toward our right. From here we will move inwards. So let's see how this algo works with a dry run. So let's first have our left, which is at 0, our right, which is at our length is 9, so our right will be at 8, position 8. Now let's have our current area and our max area. Let's dry run and update these. So initially our left is at 1, our right is at 7. Okay, so our current area would be, so between 1 and 7, 1 is smaller, so it would be 1 multiplied by, if we do right minus left and we find the width, it would be 8. So our current area will be 8. Our max area will be 8. Now we will check if the height at left is smaller than the height at right, which is true. So we will move inwards. So we will move inwards to the position 1. Now our left is at position 1. So here is our left, our right is still here. Now what will be our current area? If we see, our current area would be Between 8 and 7, which one is smaller? It is 7. So between 8 and 7, 7 is small, and then we will multiply it. 8 minus 1, right minus left would be 7. So 7 into 7, that would be 49. If we compare it to our max area would change to 49. Then we will check if our height at left is smaller than our height at right. But it is not. Our height at left is bigger. So we will move our right pointer inward. Now from 8th position it will come to 7th position. Now we will do our next iteration. So in the next iteration, our right is here, our left is here. Now let's find our current area. So in our current area, we have to see at left we have got 8, at right we have got 3. So the minimum between these two are 3. Then we will do right minus left, which would be 7 minus 1, 6. So our current area would be 18. Then we will check our current area and max area. So our max area is 49. So our current area is smaller, so we will not update it. Then we will see if our 3 is small or 8 is small. As our 3 is small, so we will move inward. So our right will move inwards. So now we have got 6th position, which is here. So as we are here, we will again compute our current area. So between 8 and 8, which one is small? Both of them are equal. So it would be 8 multiplied by 6 minus 1 would be 5. So that would be 40. So we will compare between 40 and 49. So our max area won't get updated. Now as both are 8, we can either move our left, as we have put this condition, so we will be moving our uh, right only because we don't have equals to. So let's move our right only. So it will now come to 4. Like we will have this in 5th position. Let's. So our 4 is of course smaller than 8. So it will be 4 multiplied by 5 minus 1 will be 4. So it will be 16. So 16 into 49 we will check. So of course it will stay 49. Then what will happen? Between 4 and 8, of course 4 is smaller, so we will be moving inwards. That is from 5th we will come to 4th position. Now what will happen? Now between 5 and 8, 5 is small. We have to find the minimum height. Then we have to multiply it with the width, which would be right minus left. 4 minus 1 is 3. So that would be 15. It is still smaller than 49, so we will not update maximum area. And as our 5 is smaller than 8, we will update our right. So from 4 it will come to 3. That is 2. So between 2 and 8, 2 is small. 2 is small. So it will be more like 2 multiplied by the distance between them is also 2. That would be 4. So our max area won't get updated, and our right will move further to this, further inward, as our right was small. So at the position 2, what will happen? We will find our max area. So at the position 2, between 8 and 6, sorry, between 8 and 6, our 6 is smaller. So 6 into 1, that would be 6. So our max area won't get updated. But in the next iteration, our right will move to 1. Now our right is 1. So no longer it satisfies this loop, and we will come out of the loop and we will return max area. So yeah, this is how you dry run it, and we can see that the two pointer approach works for this problem. So you can go on ahead and dry run some more examples. I will move over to Leetcode and show you how to write the code for this. Let's initialize our left to 0, our right to length of height -1, and let our max area be 0 initially. Now while our left is smaller than right, what we will do is we will write our current area. We will find our current area, so that would be minimum of height of left and the height present at the right index, and we will be multiplying it with the width, that is right minus left. And to find the max area, it would be max between the current area that we are finding and the max area. Meanwhile, we will check if height of left is smaller than height of right. We will increase our left by 1, that is we would bring our pointers inwards. Else, if our height in the right is smaller than the height in the left index, then we would bring our right pointer inwards. And in the end, we will be returning our area. Yeah, so let's run this. Yeah, so our test cases got accepted. The 2 test cases. Let's submit it to see the rest of the test cases. Yeah, so this is the logic behind the logic that we have implemented behind this problem. So yeah, that would be pretty much it. Thank you for watching. I'll see you in the next video.